All right, this is section 7.3. It is the homework assignment, page 435, numbers 2 through 58, every other odd. And this is the worked out version of page 435, 1 through 57, every other odd. All right, the first problem says we have the square root of 7 times the square root of 2. Remember, when you are multiplying radicals that have the same index, so both of my indexes here are 2, you can multiply underneath the radicands together. So we would end up with the square root of 7 times 2, which in this case is the square root of 14. We haven't learned how to simplify radicals yet, so we're just going to leave it the square root of 14. Next we have same situation. It is the cube root of 4 times the cube root of 9. So we're just going to write them both under the same cube root. So 4 times 9. We know that 4 times 9 is 36. So it is the cube root of 36. Again, we don't know how to simplify radicals yet, so we'll just leave it as the cube root of 36. On this problem, the approach is the same. You take the indexes are both 2, so we can go ahead and multiply together the radicands. All right, so we take 7 over x times 2 over y. We know that 7 times 2, remember when you're multiplying fractions, you just multiply straight across. So you take 7 times 2 is 14. X times y is just xy. And so our answer is the square root of 14 over xy. All right, in this problem, we're going to go ahead and use our quotient rule, which in the past problems we've been using the product rule. So we have the square root of 6 over 49. So I'm going to break it up into the square root of 6 over the square root of 49. As long as I keep that common index, I'm okay. We don't know what the square root of 6 is, so we're just going to go ahead and leave it as the square root of 6. But we know that the square root of 49 is 7. So our answer becomes the square root of 6 over 7. Okay, here we have the the fourth root of x cubed over 16. So we're going to approach it the same with the fourth root of x cubed over the fourth root of 16. Notice that I kept the fourth root here and here from the original problem. You want to keep your indexes the same. We don't know what the fourth root of x cubed is, so we're just going to go ahead and leave that alone. But the fourth root of 16 we do know is 2. So we can clean it up, and that becomes the fourth root of x cubed over 2. Okay, on this problem, we're going to approach it exactly the same way. We're going to use the quotient rule, and we're going to say the fourth root of 8 over the fourth root of x to the 8th. Okay, remember that you want to keep your common index. We started with the fourth root, so in our numerator we have the fourth root, and in our denominator we have the fourth root. Now, we don't know what the fourth root of 8 is, so we're just going to leave it the fourth root of 8. However, the fourth root of x to the 8th, we can take our index and bring it back around here to become our denominator, just like in the past we took our denominator and brought it around to our index. So this becomes x to the 8 over 4, but we're not going to leave it x to the 8 over 4. So we're going to go ahead and clean this up even more, and we're going to say the fourth root of 8 over x squared, because 8 over 4 is 2. And that will be our final answer for number 21. Okay, same approach here. We're going to take the square root of x squared y over the square root of 100, keeping our common index of 2 for both of these. Now I can break this up into the square root of x squared times the square root of y, if that helps you see it better. And then we know the square root of 100 is just 10. And the reason I broke up the numerator is because we can go ahead and remember, we know that this index is a 2. So we can slide it around back and make it our denominator. So it would become x to the 2 over 2 power times the square root of y over 10. But we know 2 over 2 is just 1. So it would actually be x times the square root of y over 10. And that would be our final answer. Now, when we're approaching this one, make sure you're paying attention to this negative out front. We need to make sure that we keep the negative with the problem the whole way. And we're going to break it up into the cube root of z to the 7th over the cube root of 27x cubed. Now, make sure you bring your negative out front. The cube root of z to the 7th. If we take 7 divided by 3, okay, I want you guys to think about this. When you're talking about z's, 7 z's, z times z times z times z times z times z times z. Okay, in order to be able to pull them out front, I would need 3 of them. You always need the amount of the index in common in order to bring them out front. So you can count it. 1, 2, 3. That means I can bring 1 z out front. 1, 2, 3. That means I can bring 2 z's out front. And then I always box however many I have left so I know what to write. So I can bring 2 z's out front. So then that's z times z, which is z squared, times the cube root of whatever I have boxed, because that's what I have left, which is just 1z. So that becomes z squared times the cube root of z. And then in the denominator, I can break it up into the cube root of 27 times the cube root of x cubed. Okay, so my numerator is going to stay the same. Z squared times the cube root of z. And then over the cube root of 27 is just 3. And if I were to bring the index back to my denominator, you would get x to the 3 over 3. And we know that 3 over 3 is just 1. So our answer is z squared times the cube root of z over 3x. All right, now we've made it into the simplification part of the homework. So we have the cube root of 192. So as I said in the last example, when you're trying to simplify a radical, you're going to look at the index. In this case, my index is 3. So anytime that I want to be able to pull a number out in front of the radical, I need to have 3 of that number in order to be able to pull it out into the front of the radical. So I need to ask myself, I'm going to make a factor tree. What times what gives me 192? Now on this, if you have a calculator, you can figure out what the factors of 192 are, or you can always just divide it by 2 since it's an even number. I know that 16 times 12 gives me 192, so I'm going to go ahead and start with 16 and 12. And as soon as I take the factor of something, I cross it out, so I know later on when I'm circling what's left that 192 is not one of my options. So then I'm going to say what times what gives me 16. I'm going to go 4 times 4. And then what times what gives me 4? 2 times 2. And then what times what gives me 4? 2 times 2. What times what gives me 12? 3 times 4. Cross out the 12. What times what gives me 4? 2 times 2. Cross out the 2. Now you'll see that I have a gazillion numbers floating around right here that it comes in handy to go ahead and cross those things out because then they won't come back to haunt you later. Now, because my index is 3, I need a number to repeat 3 times before I can bring it out front. The only number that repeats at all is 2. So I'm going to go 1, 2, 3. That's 1, 2 I can bring out front. Then I'm going to go 1, 2, 3. That's 2 2's I can bring out front. And the only thing left is a 3, and I put a box around it so I know that's what's going to go under my radical once I'm done pulling things out front. So I have 2 2's going out front. So that's 2 times 2 in the front, and then the cube root of whatever's left, which is just my 3. Now we're never going to leave this 2 times 2 because we know that 2 times 2 is 4. So it's going to be 4 times the cube root of 3. And that is our solution. That is the simplified version of the cube root of 192. Okay, now I'm going to do the same thing for the square root of 24. But this time, since I'm talking about a square root, I'm going to need 2 times of a number being repeated before I can pull it out front, because we know that there's a 2 right there when we're talking about square roots. So when I break up 24, you can do 6 and 4. You can do 12 and 2. I'm going to do 6 and 4. And then what times what? Cross off the 24 once you're done. What times what gives me 6? I'm going to do 3 and 2. And then what times what gives me 4? I'm going to do 2 and 2. Now, in order to pull a number out front, I need 2 of them in this case. Let's cross out my 4 there. Sorry about that. So I'm going to say 1, 2. That's 1, 2 I can pull out front. And then I've got a 2 and a 3 left. There's nothing repeating. So I'm going to box my 2 and I'm going to box my 3. And that's actually what goes in under my radical. So I know I can bring a 2 out in front of my square root. Then I've got the square root of 3 times 2, because I was left with a 3 and a 2 here. So again, we know what 3 times 2 is, so we can go ahead and multiply those together. So the reduced version of the square root of 24 is 2 square roots of 6. All right, now I've got the cube root of 16y to the 7th. So I'm going to break it up. I'm going to say the cube root of 16 times the cube root of y to the 7th. Okay, now that's just doing the product rule backwards, and that's going to make my life a little bit easier when I go to make my factor trees. So here I'm going to say 16. Now how many times do I need to have something repeat in order to be able to pull it out of the front? In this case, 3, right? Whatever my index is. So I need a number to repeat 3 times before I can bring it out in front. So what times what gives me 16? You can go 8 and 2. You can do 4 and 4. What times what gives me 4? 2 times 2. What times what gives me 4? 2 times 2. And I said I need 3 of a repeated number in order to bring it out front. So I'm going to go 1, 2, 3 2s that I can bring out front. So I can bring 1, 2 out front. And then I'm going to box the last thing I have, which is a 2, and that goes in under the radical. So it's 2 times the cube root of 2. And then I need to deal with this cube root of y to the 7th. Now you can look at it one of 2 ways. You can either write 7 y's, okay, and then count how many. You need 3 still in order to bring 1 out front. So I've got 1, 2, 3. That's 1 y I can bring out front. And then 1, 2, 3. That's 2 y's I can bring out front. So I'm going to bring 2 y's out front, which is y times y, which is y squared. And I'm going to put a box around what's left, which is what's going to go under my radical, which is just the cube root of y. So now I need to bring both of these back together again. I'm allowed to do so because I have the same index. So I'm going to multiply my outside terms together. So I have 2y squared times the cube root. And I'm going to multiply the radicands together, which would be 2 times y, which is 2y. So my final answer is 2y squared times the cube root of 2y. Okay, for number 45, we're just going to simplify the square root of y to the 5th. Now we know that there's a 2 out here, so it is the square root. You can do this one of 2 ways. You can say y times y times y times y times y 5 times, and you would need a number or variable repeated twice in order to bring one of them out front. So I've got 1, 2, that's 1 y I can bring out front, 1, 2, that's 2 y's I can bring out front, and then remember I'm going to box whatever I have left. So out front I have y times y, which is y squared, times the square root of y. Okay, now that's one way. Another way you can do it, and this is how a lot of people see it. Remember that we can bring this index back here and put it underneath the 5. So if you can see in your head that 5 divided by 2 is 2, and then you have one more y left over, then you would know that 2 are going to come out front, and 1 is going to be left on the inside. So a lot of people can just visually see that. If you can't, that's no problem. Draw your 5 y's, put the ones that you're going to take out front in circles, and then box the one that you're going to keep in the radical. Either way is perfectly fine, and you'll get to the same answer. All right, now we're dealing with the fifth root of negative 32 x to the 10th y. So I'm going to use the product rule backwards, and I'm going to say the fifth root of negative 32 times the fifth root of x to the 10th times the fifth root of y. Okay, so we know the fifth root of negative 32 is negative 2. We know the fifth root of 32 is 2. And remember, if you have an odd index, it's okay to have a negative under your radical, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. So that's okay. And then here we have the fifth root of x to the 10th. So I know I can take this index back and make it my denominator. So this is going to become x to the 10 over 5, which we will later change to 2. And then on fifth root of y, we could move it back, our index back to our denominator, but there's really no reason for that. There's really nothing we can do with the fifth root of y, so we're just going to leave it the fifth root of y. So to clean this up a little bit, it becomes negative 2 x squared, because 10 divided by 5 is 2, times the fifth root of y. So that is our final answer. Okay, here we have the cube root of 50 times the cube root of x to the 14th. Okay, so the cube root of 50, it's not a perfect cube, so we're going to have to go ahead and start breaking it down. What times what gives you 50? You can do 10 and 5, you can do 25 and 2. I'm going to do 10 and 5, and then I'm going to break down 10 to 5 and 2. Don't forget to cross them off once you're done. Now 5 can't go any further other than 5 and 1, so we're not going to do that. 2 can't go any further, 5 can't go any further. So are there any numbers that repeat 3 times in order for me to bring them out front? There really isn't. So we know that we can't go any further than the cube root of 50. It cannot be simplified any further than that. Now here is the cube root of x to the 14th. Now remember, you can do this one of 2 ways. You can take the index back and make it my denominator. Okay, you know 14 divided by 3 is 4. So you're going to bring 4 x's out to the front, so x to the 4th. And then how many are you going to have left behind? Well, 3 times 4 is 12, so you would have 2 x's left behind, and they would go in under your radical. So you would have x to the 4th times the cube root of x squared. Now, not everyone can see that. So if you can't see that, you're going to do that where you write the x 14 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, how many x's do I need in order to be able to pull 1 out front? Because my index is 3, I need 3 x's. So I'm going to say 1, 2, 3. That's 1 x I can bring out front. 1, 2, 3. That's 2 x's I can bring out front. 1, 2, 3. That's 3 x's I can bring out front. 1, 2, 3. That's 4 x's I can bring out front. And then the last 2 must go under my radical. Okay, so again, we said that you can bring 4 x's out front, so that's x times x times x times x, which is x to the 4th. And then we have 2 x's going under my cube root, which is x squared. So either way, we got to the same answer, here or here. It doesn't matter which way you do it. One person isn't smarter because they did it one way or the other. Either way will get you to the correct answer. It does not matter which way you do it. So we're left with the cube root of 50 times x to the 4th, the cube root of x squared. Because my 2 indexes are the same, I can multiply the radicands together. So I've got this x to the fourth I'm going to keep out front, and then I'm going to have the cube root of 50 times x squared, which we know is 50x squared. And that is your final answer. Okay, we've got the square root of 9x to the 7th, y to the 9th. Let's go ahead and break it up. Square root of 9 times the square root of x to the 7th times the square root of y to the 9th. That's a 9. Sorry about that. That didn't make it any better. Let's try that again. 9. Oh, anyway, it's a 9. All right, we know that the square root of 9 is 3. The square root of x to the 7th, remember this is a 2 here. So we can bring it back and make it our denominator, 7 over 2. You know that 7 over 2 goes 3 times with 1 left over. So it would be x cubed and then just 1x on the inside. If you didn't get that, you would say x times x times x times x times x times x times x 7 times. And you're going to need 2 in order to pull 1 out front. So I'm going to go 1, 2, that's 1 out front. 1, 2, that's 2 out front. 1, 2, that's 3 out front. And then 1 stays behind. So again, 1, 2, 1 out front, 1, 2, 2 out front, 1, 2, 3 out front. So it ends up being x cubed out front, and then this x left behind is my x that's underneath my radical. So either way, getting to the same answer. Here, again, you can bring back the 2 and say 9 divided by 2. 2 goes into 9 4 times with 1 left over. Okay, so that means I can bring y to the 4th out front and then put the square root of y left underneath the radical. Or you can say y times 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 y. 9 times, right? You need 2 in order to be able to pull 1 out. So 1, 2, that's 1. 1, 2, that's 2. 1, 2, that's 3. 1, 2, that's 4. And you have 1 left behind. So, just like we said right here, 1, 2, 3, 4 y's came out front with 1 left behind. Either way, got to the same answer. Now we need to combine them. Because I have an assumed 2 here and an assumed 2 here, I can multiply the radicands together. But first I'm going to multiply everything that I have outside together. So I have 3 times x cubed times y to the 4th. So that's 3x cubed y to the 4th times the square root of my radicands, which would just be xy. All right, last but not least, we have the cube root of 125 r to the 9th, s to the 12th. So again, I'm going to use the product rule backwards to break it up. The cube root of 125 times the cube root of r to the 9th times the cube root of s to the 12th. Man, they were nice to us on this last one. We know that the cube root of 125 is 5. The cube root of r to the 9th, we can take our index back and put it underneath our exponent, and you get r to the 9 over 3. And then with the cube root of s to the 12th, we can bring our index to the back here and make it our denominator, and we get s to the 12 over 3. Now both of these fractions reduce nicely, leaving us 5r. 9 divided by 3 is 3. S, 12 divided by 3 is 4. So our final answer is 5r cubed s to the 4th. Okay? And you are done watching my video and hopefully done with your homework. So have an awesome night, and I will see you guys tomorrow.